better his way or no?
Yeah.
Yes.
Good. Because there is a reflex there.
Okay. So. Okay. A very brief historical note. You know, Newton Acosta and Stanisław Jaskowski were the guys we started the idea of formalizing paraconsistent logic. The idea existed before then, but nobody had formalized it. So, in my opinion,
who began it?
Huh?
Who began it before?
Well, there was Vasiliev, a Russian guy in 1912, and the other people. I mean, Vasiliev had this idea of non-standard geometry, non-Euclidean geometry. Non-Euclidean geometry, comparing non-Euclidean geometry to the possibility of a non-classical logic, right?
Yep.
But he was more philosophical, so it's not find any concrete thing. And then, in my opinion, the two guys we started it were Newton Acosta and Stanisław Jaskowski. Jaskowski in Torun sort of gave a very nice way of understanding semantically contradictions by means of his discursive logic, where he could explain contradictions in like a meeting of many people talking rational things together, and all together they would be contradictory, but that does not mean that real contradictions exist in the world. Just is more an epistemic thing or a philosophical thing or a linguistic thing, etc. And Newton Acosta gave the first very well done axiomatics for paraconsistent logics. They were working independently and they knew each other later on. But then,
sorry, can you write the name of the person?
yes, sure.
Get
Of course,
it.
yes, please. Oh my God, I'm sorry. I'm very sorry. I hope I did not destroy it.
Okay.
Stop to ask, Alex.
Yeah, I was thinking I should have asked.
No. I'll be using this one. No, I'm very sorry.
Okay.
Oh,
Chapman property. So.
Totally fine. Yeah, we have to do this. No problem.
wow, it's a bit of a dangerous wiring. Huh?
Yeah.
Lots of.
They don't
I'm not.
mess
Hope they won't
up
set
with these
We are
fire.
not with work after all, it's a conference of paraconsistent logic, so we can have a paraconsistent conference too.
That happens all the time.
This is why.
Well, I don't work.
Did I destroy
So I
it?
can tell you whatever.
Chapman property is very resistant, very well. I'm very sorry.
Of course, it's upper.
No,
Good.
no,
Yeah, it's Apple. It can take.
Yeah, but yeah, exactly. I wanted to. Oh,
Throw it away, please.
No, Jaskowski.
So this guy in Torun and this guy in Paraná. They, in my opinion,
That died last year, no?
yeah.
2 months ago.
2 months, some months ago only, because he was a sort of a house accident.
Out of an accident.
Very nasty house accident. He was,
You step on a cable of the computer.
yeah. No, that's the way I'm going to die. That's the future. So he was just, it was dark room and he was like to lie in the bed and missed it. And hit the soil, you know, he bumped his head, the soil. Well, was
19 years old, no?
94.
94.
94 years. Very active,
He
yeah.
was still very active.
Very active, yeah. One year ago, he was giving a lecture on in somewhere in quantum mechanics or some of his ideas on quantum mechanics, blah, blah, blah. Anyway, right or wrong, but he was doing. So those guys are responsible for the first attempt is to formalize paraconsistent logic. Stanisław Joskowski more in the semantical side, Newton da Costa more in the syntactic side. And I was a student of da Costa, and I did not like paraconsistent logic because I found them a kind of a mistake. A mistake I found, actually two kind of, not mistakes, but points to discuss. The first is that Newton da Costa, he defines something as to be, he understands or he proposes that the world has some contradictory statements, and some of them are really contradictory, and some of them are nice and like solid, consistent, or something like that. And the idea of something to be consistent, this is not the case that I have A and not A. So what's the problem here? So the problem is that I can have something contradictory like A and not A, or A, comma, not A together, but when they are really consistent or well behaved, as we call it, it means it's not the case that A and not A. So the problem is, this guy is a kind of soft negation. You can stand it. You can stand two contradictory objects by a kind of soft negation. But the same negation works in a very hard way outside. So,
What is this distinction between soft and hard?
Excuse me?
This distinction between soft and hard.
No,
is
it's
what?
just a let's say it's just a positional distinction.
Is intention negation, and the other is negation that say that you cannot do it.
Yeah,
But how
yeah.
do you know? Like, I mean, they look the same to me. So
These are the
how do you
same.
know that?
That's
they're
my
different?
philosophical point. They are the same. Just by standing in different positions, they acquire different philosophical perspectives. That's the way I did not like it. That's the way I never worked in.
Okay, so can you explain this different philosophical
No,
perspective?
philosophical is like that. So you can have, in the world, you can have contradictory things like it's hot here and it's not hot here. There's a kind of a soft negation, right? Because nobody's going to be crazy because of it's hot here and it's not hot here, or it's cold here and not cold here. Nobody's going to be, crazy enough to deduce that the Pope is married with Madonna.
Yeah.
Okay, but okay, so this is not really good, but not really bad. You can understand
Now
it.
I understand what you're saying.
Okay, but then when you put this negation outside, this means don't do that. Never do that. It's forbidden to say that. So the same negation acquires different perspective because of the position. And that's one thing I did not like. And the other thing I did not
So
like.
can I just ask again? So what you didn't like is that there's now a mismatch between the philosophical reading and the formal reading.
Yeah,
Because
exactly.
formally they're just the
Yeah,
same.
yeah.
Okay, okay.
Exactly.
Okay.
That's perfectly. The other thing I did not like personally, and then Da Costa was completely in agreement to me. Say, okay, if you don't like it, don't do it. Do some other thing. Okay, no problem. Okay, and that's what I did in my life. And later on, I returned to this kind of thing. And the other thing I did not like was that paraconsistent logic had no good semantics on it. You could not explain to a computer what a contradiction is, because in Da Costa terms, his way of understanding semantics and had a completeness theory and blah 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 was something like that. You give zeros or one to sentences, and you can say, okay, sometimes you can have V of A and V of no A equal one equals one at the same time. So true at the same time. Why? It can be mathematically. It's okay. So mathematically, it works very well. He could give a completeness proof, not only to his system, but to a family of a system named CN systems, or infinite families of paraconsistent logics. Each one is stronger than the other one, actually weaker than the other one, and up to a certain limit, blah, blah, blah. And then that worked, they stayed for like 30 years, this kind of thing, nobody really paid much attention to it. And then I had the idea, together with my student, to sort of make a reformation on these ideas. And then we started the idea of a possible translation semantics, where we, very simply, we don't talk about that anymore, but we have a new connective, which works like make it has this meaning, right? It's well behavior or consistent or coherent, right? And then this is completely different from to be contradictory in principle. You don't need to connect them. You don't need to connect them by giving a new connective, by employing a new connective in the language, by this is a unary connective as good as negation. Nothing forbids you to think about that. And then this comprises the family named logics of formal inconsistency. And we were able to give a new interpretation to that. That's what I'm going to show you today. Okay. So that's the story. But you can ask me, please. I promise not to stump over computers anymore. No.
Can I ask, I mean, one can.
Okay, that is working. Don't worry. Excuse me, yes.
One can also like have two different negations, like one being this absolute like failure. If it happens, then it's
Sure.
bad. And one can simply just denote that, okay, like this is like I mean, I have negative attitude towards this.
Yes?
And then is there some way of seeing it like that?
Yeah.
That-
Now,
that
the idea is the following. In this logic of formal consistency, you start with a very mild and weak negation, and
Yeah.
then you can define the strong one.
Oh, sure, yeah.
Yeah?
Okay,
Okay, so
then, yeah, then it will end up.
the notion of the main idea is that the notion of the consistency and inconsistency can be formalized in the language. So this white ball means A is consistent, and black ball A is inconsistent. The correct word. So the idea is that contradictions can be friendly. You don't have to throw away your reasoning. You don't have to step back to your reasoning if you find a contradiction, because they can be friendly. Inconsistency is not the same, it's different in principle of contradictions. Contradiction and inconsistency are not the same. They can be made the same by means of employing some additional actions. So you have to pay the price of putting actions if you want them to be the same. In principle, they are not.
So which one is worse? Contradiction or inconsistency?
Excuse me, say it again.
Which one is worse? Which is the hard one and which is the soft one?
What
You say they're
bring to explosion?
different.
Which one bring to explosion? Inconsistent or contradiction?
No. I'll explain. None of them. They avoid the contradictions. Okay.
Okay, so
inconsistent-
then what is the difference?
No, but
When you say they're different, you're appealing to. I mean, I need to understand what.
Okay, I would.
I think that the question is, what is the difference between inconsistency and contradiction? That's the question, no?
Yeah, exactly. So I thought it's related to the hard and soft thing, but maybe I was wrong.
The idea is that's the idea. If you have, I will explain that in the next slide, but I advance it. A and not A does not bring you any triviality in this deductive triviality. Okay, so you can have in this weak negation, this soft negation, you can have two contradictory statements like it's code here and it's not code here, and they are not going to explode. They are not to be able to derive every possible sense. But if you have something consistent and contradictory, then it explodes. Like my banking account has to be absolutely coherent, right? Even with sense. If I find two different bank statements in my account, that's horrible. I cannot stand it. I have to go to the bank immediately. Or
I understand what you're saying, but I don't understand how to turn this into a definition of
Inconsistency
inconsistency and
given-
into a definition of contradiction.
it's not a definition.
No, but I mean, if you say they are different, I guess you have a definition in mind, or
Yes,
not.
I mean, the idea like that, this symbol, this is a logical symbol. And the idea is that if you have a inconsistent, that entails a contradiction, but not vice versa.
Yeah,
Inconsistent is bigger, is a bigger concept. Something can be incoherent. Just being contradictory is just one possible side of it.
Does contradiction implies inconsistency or the other way around?
Inconsistent implies contradiction. This way around,
Inconsistent.
you need to put an extra action.
So contradiction, let me correct me if I'm wrong. Contradiction is the conjunction of a formula and its negation.
Yes,
That's a
contradiction, like
That's a
Latin.
contradiction.
Yeah.
The conjunction of a formula and its
Contradictere,
negation.
huh?
And then inconsistency is another,
Inconsistent are not the thing which is bigger.
is another predicate.
Another predicate. Okay, suppose, what are examples of
What do you mean by
inconsistency?
that?
Like it,
You mean that
It's a different one.
in the Venn diagram, contradiction is a subset
It's a-
of inconsistency, or what do you mean by
No,
bigger?
No,
other way
it's-
around.
No, it's
That's the
another.
problem.
no.
So-
You-
But then when we use the word bigger in
No,
in
it's
Calvin.
Stronger.
it's stronger. It's a modality.
Mathematics
That's a
is not
modality.
applied for
I
it.
didn't say bigger.
You didn't say bigger.
No,
Oh, sorry.
no, but I
Misheard.
I said it's a different thing. It's
Bigger, but
another
he meant
predicate.
stronger.
So a modality.
Let's see.
When you mark A with the modality
In
black,
consistent, contradictory,
Yeah.
the other
yeah,
way
yeah,
around.
Yeah,
The
No, that's
other way
that's-
around, says Peter.
No.
And Walter
It's
says-
correct.
No, this is bigger concept. If you have it, you imply that. Okay.
So contradictory
It's
here.
the other way around.
Consistent, more things are inconsistent than contradictory.
Now we are being inconsistent.
Stronger, not bigger.
Not contradictory, but inconsistent.
Yeah.
So the Venn diagram.
I don't believe it.
Contradiction and consistent.
No, then
Well, in
it's,
this
So
case,
Peter doesn't
inconsistent-
believe it.
In this case.
That would be the other way around.
inconsistent Does not imply contradiction.
Yeah,
that's the other way
Contradiction is a
around.
subset.
Yeah, now
Another way
contradiction.
around.
No,
Now
contradiction
contradiction implies.
If something is here, it is here. If X is here, it is here.
yeah,
Not
then
vice
it's,
versa.
then it's the other way around, then you wrote it
That's
there.
not what we want.
So this way,
Yes.
I think
That's
it's
now
very
we
simple.
agree.
Sorry.
I think we're speaking about different
I'm being confused
formulas.
myself.
The formula
Yeah.
contradiction, a formula is a contradiction if
No,
it is
no.
the conjunction of
I
a
have
formula
everything.
and negation.
Yeah, and the
That's a
formula is
contradiction.
an
And
inconsistency.
a formula, an inconsistency is a formula that starts with the modality black dot A. That's a contradiction.
Yes,
Yeah.
But then
I'm very
to
confused
say
myself.
that they are not, it's kind of not a very interesting thing to say because they are already
Okay.
syntactically
Exactly.
completely different
Exactly.
categories.
So what, I guess that
So
what by
that-
not
that's kind of
equal,
confusing,
yeah,
right?
not equal means that they don't have the same strength within the deductive system. Within the deductive system, every time that you have the modality black dot A, this is going to imply the contradiction A and not A, but not the other way.
Yeah, I wrote it wrongly. If something is contradictory, it's
Okay.
inconsistent. That's it.
Okay.
Can you use
Something
it
is
Then
okay.
it's wrong now. because
Yeah.
we changed.
If something is contradictory, is inconsistent. But inconsistent is a bigger concept. Why and how? Because inconsistent means like he not be well tuned in music, or not if I'm wearing a red trousers and a blue jacket, that's not really beautiful in terms of combining colors. Okay, so inconsistent is a bigger concept. That does not only means that it comes from two negation side.
so that's his division, it's not this way, the other ways around.
Yes, Marco, what you
It
have.
got changed.
What I wrote before was correct.
But it was.
That's it. Maybe I wrote it wrong.
No, we
Okay,
just,
let's
He
do
says
it smart
that
before we
thing.
change the wrong thing.
just continue with the talk, you'll see the axioms, it will become
And that's
clear.
it.
Next slide.
It is
Yeah.
consistent, it's not contradictory.
Yes, okay.
It is consistent, it's not contradictory.
Yeah, I mean, this makes more sense that
Yeah,
like
yeah,
there's more ways to be inconsistent than just
But I
being
mean,
contradiction.
you can make it, you can make them to be
Makes sense.
equivalent just by putting special
We
accent.
need to understand that, that's.
Okay, but for me, the important point is to understand that inconsistent is a bigger concept than contradiction. But it's just one way
Yes,
to be wrong, let's say. You can be wrong in other ways, okay? Okay, then I will talk about some etc. Contradictory theories do exist. I would like it to just to convince you that contradictory theories exist everywhere. In our speech, in political statements, and etc., in science, everywhere, in databases, right? I think you are convinced of that. So Newton Acosta allowed closed door assumption, for instance, it may lead to a contradiction. Newton Acosta stated a principle of intolerance in mathematics, which is more or less as Carnap's principle. So from the syntactical semantic standpoint, every mathematical theory is admissible unless it is trivial. So for him, to be trivial is the worst possible thing. To be contradictory is not like that. So he was then in the beginning trying to construct some theories which could be contradictory without being trivial.
Trivial means that.
Trivial means you
any formula
derive
can-
everything.
Like,
Deductively trivial, deductively explosive, right? If it's trivial, it has no value. If it's just contradictory, it's okay. Like this is more or less the same position as a Wittgenstein had when he said, why this thorn in our speech? Why people are so afraid of contradiction? Isolate them. They can be useful. More or less same independently. This was, I mean, idea is much more widespread than we can think. So how can you make profit from a contradiction? Like financial authorities are very happy to find a contradiction in your IRS statements. Everywhere in Brazil, especially. Yeah, I've been called myself. Explain this here. So they are very happy. Call you there, you can explain, they find you. Yeah? Police investigators, for instance, they can make a question to two suspicious people. Have you and your friend been in the same place last week? A crime was committed. If you both say yes, if you both lie, or both say no, they don't know what to do. But they are very happy if they find a contradiction. That's why they interview people in different rooms, right? If one of them say yes or they say no, good. Contradiction is our way to start my investigation. So it's so obvious that people don't realize it. Contradictions can be very useful in reasoning, in human reasoning. But they are not beautiful, they are not nice in mathematical reasoning. And that there is a gap to be filled between good mathematical reasoning and the human reasoning. And paraconsistent logic tries to bridge the gap. Right? So only if a contradiction appears, we can be sure to have received one information. So contradictions are not exactly the same as inconsistent. Contradictions like antinomy, for instance. Russell's paradox is an antinomy, and Curry's paradox is a kind of inconsistent because it has no negation on it.
So what was Curry's paradox?
Curry's paradox is that you can, using the truth predicate, and using this law, A implies B, you can prove in a set theory with the truth predicate that everything can be derivable without needing any contradiction to that. No, you don't want needing any presence of contradiction. It's a positive. I think it's more a bit more complicated because you need to appeal to a truth predicate.
So is the definition of inconsistency that everything is derivable?
No.
Okay,
I mean,
so then how
everything
does
to
your
be derivable is,
explanation relates to-
yeah, everything to be derivable means the deductive triviality, right? Or trivialism.
Mhm.
So let's make I imagine that kind of analogy is just an analogy, okay? Think about this consists as imaginary numbers. Think for a moment that the real numbers are divided, good complex numbers are divided into real numbers and real complex number. You can divide them. And then if you think about A and not A can be regarded as if you do A multiplied by minus A. You can regard, this is a nice analogy. I never did more than this here. Maybe there's some idea behind it. So if you say that I multiplied by minus A is equals 1, it gives you A squared minus 1 and then 2 roots. You can solve this equation. But you can only solve this equation if you view this A belongs to R to be something coherent or consistent, and A being outside of the real numbers, like an inconsistent, being an inconsistent be regarded as I does not belong to the real numbers. I belongs to the complement of a complex between numbers. Then you can find a solution. Otherwise, you cannot. So I think this, in my opinion, this analogy is illuminating, because as much as people have invented a new sign for real numbers, why cannot you invent a new sign for being coherent or consistent? It's a concept. It's a philosophical concept. People took hundreds of years to understand that. But now everyone thinks it's clear and useful, etc. Right? This is just an analogy. I would be very happy to try to find a semantics using complex numbers to explain paraconsistent reasoning. I could not. I just stopped here. Maybe you guys are clever and can do that. But would be interesting, you know? I know if this is
Consistent would be the complex number and contradictory the imaginary.
No, contradictory, no. Contradictory would be the possibility of multiplying, of solving this equation here. If you try to solve this equation, a squared equals -1, you cannot solve it, real numbers. If you decide that the real,
I know.
you know very well. You cannot solve it if you decide that numbers are only real numbers.
Yeah, of course.
Okay, so if you decide that numbers are something consistent, well done, old things, historically well defined, real. Then if you enlarge your domain and you suppose that numbers cannot be only real numbers, they can belong to a large domain, they introduce complex numbers and then you can solve it. So you can regard in analogy, inconsistent as to be belonging to the complex part and consistent to be belonging to the real part. Just as an analogy, okay? This is not logic. I'm trying to find a mathematical analogy.
In this case, with this analogy, it wouldn't be true that if it is inconsistent, then it would imply a contradiction.
Yes, if in a symbolic sense, if it's a complex number, implies a contradiction in the sense that the equation can be solved.
It cannot. So, for example, you could have 2i. 2i is not a real number, but when you multiply 2i times -2i, this does not give you 1. So,
Yeah, but I don't mean that. I don't mean to. I mean that this equation can be solved. You cannot be solved this equation.
If a is 2i.
No, but A is x.
It's not true.
X.
Okay, you have to stick to the complex numbers
X.
on the unit. So
That's what I mean. X squared equals 1 is an equation. I don't mean that every possible number is solved. That's one solution. What's the solution to this equation? I mean, complex numbers.
So
-1. This
you
expression
need
is easy.
-1 on the other side, otherwise.
Oh, sorry, minus. Obviously.
I mean is that you said let's view black dot A as A is not a real number. Okay, for example, 2i.
It's not
2i.
Okay, this will be black dot A.
No. Black dot A is the domain of making possible to solve equations. Like it's not that every number is classified as incoherent or inconsistent. It's not that every number is classified. I mean, to adopt the open position of accepting inconsistent objects is that you will accept solutions of this equation like -i or I. It's not that I'm classifying every object as incoherent. I'm asking you to consider an open position to accept that other objects may exist in the domain of numbers.
Yes. And
If you accept that, you can solve it.
yes.
That's what I mean. That's only what I mean. I don't mean to classify, okay, I know what I mean. I mean, if you multiply this number by itself, you get -4. So what? -4. -4 is not any problem. I mean, the idea is only like that. So how do algebraists discovered or invented complex numbers? Bombieri. Who else? You know history of mathematics better than me. Raffaele Bombieri.
Bombelli.
Bombelli. Yeah.
Bombieri is
Bombieri.
Italian medai field that is
Bombieri. No.
Bombelli.
Bombelli. Bombelli was astonished. He said, well, accepting these kind of things, I can solve, but I don't believe them. It's more or less here. So accepting a new position of imagining that some inconsistent objects can exist, like making the analogy of real numbers, I can solve this equation. If I don't accept that position, I don't solve that equation. And by solving this equation, I sort of obtain a new kind of mathematical object, which is I. This kind of mathematical object, which is I, is in my opinion analogous to this black ball or white ball. Let's make an analogy. Let's make it to be easier to make it palatable. We can swallow it better. Okay, it's okay or?
Yeah. My point was very technical.
Okay,
so-
okay. No. So the LFIs, logical formal inconsistent, very quickly, they are non-explosive in the sense that from A and not A, I don't derive any possible B, but they are finitely gently explosive. In the sense that if I have A and not A talking about something consistent, then I derive everything. So I sort of divided the world into two kinds of propositions.
So
Okay?
then one thing, why you need the round, the black round? Why you simply, I do not see why you need the black round.
The black round is just the negative of
What you need to have this also, you can
not
avoid it.
necessarily. In most logics, black A is not white A, negation of white A. Even with the soft negation, it works very well. But depending on the action of, on the power of logic, if you don't have, for instance, if you don't have that, not A implies E, or A implies not E, then this is not going to be good. You need this inconsistent operator as a primitive. So the inconsistent operator is either a primitive or can be defined, depending on the laws of logic. Depending on the laws of logic. So, but I mean, the philosophical idea or intuitive idea behind it is that the world is divided, if you accept it, into two kinds of propositions. Propositions that are so kind, so soft, so nice, that they accept contradictions, like it's cold here, or Marco Panza looks like a guitar player. You may agree or not. Some people say, no, I don't agree. Some people say, okay, I do agree. So this is a soft proposition. But I say Marco Panza is going to be the next Pope. Are you? Sure. Then it's hard to believe it, right? It's hard to believe it. So
You're wrong, because I will be.
will be, yeah. So before
The next pope.
need to be Christopher. Okay. And so
Well,
the idea is very simple. You divide the word. If you accept our discourse, the statements, the judgments we do every day can be divided into two categories, like we do all day. You say, I like chocolate. Well, not much. I like a bit, but you know, I like poultry, but not every day. Well, you can be on the other hand, in mathematics, you don't say that. I mean, you say all this pi is an irrational number, it's a rational number, and period. It's not more or less rational. So if you accept that position, that the world can be divided in two kinds of propositions, the soft ones and the hard ones, the soft ones accept it to be under the pressure of a contradiction, and the hard ones do not. If you accept that, okay, then you are in paraconsistent logic. That's all you need, no more. And accepting this principle here, from A and soft negation of A does not lead to any trivialization, but soft negation on about something that is hard is going to destroy your system.
This mean the classical logic is a particular case of paraconsistent.
Yeah, exactly. Perfect, you got it. So Then a classical logician would be a paraconsistent logician who regards all propositions as coherent, as consistent. Okay, so classical logicians are a particular case of paraconsistent logicians. We're not negating logic, we're just expanding logic. It's not like intuitionistic logic, right? It's just expanding. So, the meaning is this consisting is safe, uncontroversial, which cannot support contradictions or crisp.
Marco Panza will be the next.
Will be, yes, yes. Paraconsistently speaking, yes, sure. Sure, you're going to be living in Rome, beautiful palaces and so on. Examples, obvious examples, as I'm repeating myself. N is an odd number, is hard. Because, to be odd number is a very hard statement. You can, no number is more or less even or odd. Are they?
Well, if you take n to be 1/2.
I mean, talking about natural number. Man, come on.
No, this is what Peter
Saying
says,
it.
analogous to what, exactly.
Then, okay, change your neighbor to be rational or irrational.
It's what you said about the analogy with
Yeah,
the complex.
that's an analogy. Now, to be an odd number is a very crispy concept. To be a big number is not. Big number is big. So to be big number, we can disagree on what a big number is. 10, but no number is big. No number is big. There's always one big number. Okay.
So what happens then if I take n is a big number and I write a circle and I make it hard? So what happens to that statement?
Okay, for you, but who decides which concepts are hard or soft?
No, but I'm interested in if you write a circle, you can take a soft statement and make it hard.
Yes.
So
yes,
so I'm
yeah.
interested in understanding what happens to the statement when you are doing that.
Okay, very nice question. You decide. In a databases, for instance, you decide which concepts are hard, or which ones are soft. For instance, to be born, I think, to be American is a kind of soft concept. Unless you say to be American means to be born in this country, not be a native a foreign person that got a passport or a citizenship. So you decide. And that's the root of complexities in human talking, in political discussion, in philosophical discussion.
Walter, we're asking a mathematical question. If
Yeah.
A is the statement, n is a big number, and you put a white circle in front of it, it will become a false statement, because that's how I interpret your consistency. But if I put a white circle in front of a statement that's supposed to be soft, it will not suddenly become hard.
Depends on your definition. Depends on your definition. Suppose that you say for me, okay, big number is something bigger than that.
But
Then it's obviously a hard concept. I can decide it. Right? You define what, in your opinion, is a big number. If you say to me, for computer science, this is a big number.
So n is a big number. This is a formula with an open with a value, right?
Yes.
Okay, so it's not true nor false. Okay, let's say something like 10 is a big number. That's a formula. That can be true or false. When you put a ball on front of it, what you're saying is 10 is a big number is hard.
But if I understand well, this is totally
Yeah.
independent.
Just a little,
Yeah.
I mean,
Yeah.
participate in this discussion. Just a moment. Just a little moment. Excuse me.
7, 11.
Okay, Peter, suppose I'm talking about millions in my pocket, then 10 is a big number, okay?
No,
If
but
I'm talking about
that's
dollars, 10 is
our
not a big
question.
number, I have it.
Formulas with black or white circles in front of them still have to be formulas, and they should have truth values.
Yes.
So,
But you decide which list of concepts are to be classified as hard or soft.
But the formula that has the true value is
You decide
the
which one
number
is
10
actually.
is a big number is hard. This is the formula that has
You know?
the true value.
I mean, logic is not responsible for deciding which concepts are hard or.
Good point.
That's a good point,
Okay.
you know? Okay, now Marco has a question.
That is exactly.
Exactly, I saw
The
it.
question is not which is one, which is hard. Logic does not decide.
Yeah.
This the negation of the formula. When you put a ball on it, this means that formula is hard. So this is what has a truth value.
That's probably hard.
So
it has a truth value.
the formula
But
ten-
hard and soft is just a way of talk.
No, it has a truth value.
It has to have a semantic.
It has a semantic, it has a semantic, I can say.
Hard
V
is not
of
part of my formula.
this can
No,
be
it is
false.
Circle is,
Or-
but hard is not.
It is part of, it's part of the body and
The ball, yeah, but to
And-
say something is hard is not part of it.
So
It's just a way of talking.
No, it's not a talking, it's a sentence. It's a well-formed sentence. You are going to give values to it, truth or false, according to what? According to your understanding of what is to be considered hard, what to be considered to be soft. I mean, it's a matter of the application, matter of the user or the philosopher behind it. It's not a matter of logic to say which concept is hard or not. I'm trying to give you some examples, human-like examples, but of course, it's not the task of logic. Flexible meaning of logical constants. I mean, in our background, negation has more than one. I'm going to need this for building my semantics. Okay, now they will build my semantics. So if I have it to understand, because my problem is, how can I find a kind of semantic explanation that I can teach it to computers or to an alliance? Okay, so before paraconsistent logic had no meaning. I believe that we now have a very clear meaning by means of the semantics of possible translation. What is the semantic of possible translation is going back. So in a certain sense, I'm mixing Da Costa and Jaskowski. Da Costa from the syntactical point of view and Jaskowski from the semantic point of view, and we are preparing a paper in Toronto with my Polish colleagues trying to explain that kind of Thomas Jarmusch and other people. And then, I mean, the idea is that we use the translations to distinguish cases. Some cases, I mean, if I understand negation, if you are in a committee discussing something about a paper or to hire a professor or something like that, we can have a completely different opinions, right? For me, the negation is soft. For Marco, is very hard. Marco does not accept a person that does not like Bolognese Italian food. For him, it's a sin, and for me, it's not that important, and so on and so on. So we are trying to understand the contradictions and this logic in terms of a translation, in terms of a bunch of people. It's possible. Let me go to the next slide because it's okay. Just one important point here. LFIs, the logical formal inconsistent, do not validate the contradictions. It's not they like contradictions or not they look for contradictions. They just support them. They just are robust enough to make people to be able to reason, right? So. They do not invalidate the principle of non-contradiction. This is a mistake that many people do, including my dear colleague Jean-Yves Bézieux.
Please, let's speak of normal people.
Yes,
here.
let's
It's
leave
not
him out
necessary
of
to
here.
refer to-
French people, that's your department.
Not refer to
Your
anybody.
department, I'm sorry. So that's your side of the world, not mine.
It's you in Brazil that you.
Yeah, we had
We in France with the.
I did not hire him. He's crazy, but he's nice. He's nice. He's
You want
nice.
to
He's
keep
not a
you take it.
logician.
He's nice.
You know the
No,
guy?
he is not a logician.
Better.
Yeah, he's nice. He's nice. He's nice. He's making a good job. You know what he did for logic? He invented the World Logic Day.
Like he's
Oh,
hurting
okay.
a
World
lot of
Logic Day,
people.
UNESCO.
Like
UNESCO.
he's hurting
So,
discipline.
Very clever guy.
It's like completely
Not
fake.
easy to do.
He is one of the three best logicians ever existed.
I know him since I was a patient.
I'm quoting him.
I know him.
He
since-
said.
Ah, okay.
You know this.
Okay, it's like to be give a certificate today. I'm not crazy, right?
One of the things that you did.
I certify you that I'm not crazy, right? More or less like that.
I don't know, like
Okay, so They do not validate the principle of non-contradiction. The question is only the principle of explosion. And here we have a kind of disjoint philosophical positions between the Brazilian group and the French and the Belgian group, by the way, the Israeli group and the Australian group. The Australians, led by Graham Priest, my dear friend Graham Priest, thinks that the world is contradictory. I mean, you need the contradictions in the world to explain paraconsistent logic. Like you need a stone that is round and not round, square and round. You need that in the world. There are. I don't know where. There's just one example, the liar paradox. He gives this example forever and say, okay, wait till you see more.
Why is an example of liar paradox?
Liar paradox is a real, according to Graham Priest, is a example of a real contradiction. You cannot overcome it. It's real in the world. I mean, it's the world was constructed in such a way that like energy is governed by certain laws, reasoning is governed by a certain laws whereby liar paradox is a stone, is a thing that you cannot circumvent it. There's no way to go to make it acceptable in our reasoning. We don't need that. We just don't need that. For us, contradictions can appear in reasoning, in words, in poems, in music, in colors, whatever, in databases. So, okay. So the problem is the principle of explosion. We are just contradictory. In my view, in our view, paraconsistent logic is just a way of controlling the law of explosion. Nothing else. Okay.
So for a Grand Priest, classical logic is not a particular case of paraconsistent logic.
No.
Classical logic is simply wrong.
Yeah, simply wrong.
Yeah, you could say that, yeah.
Okay.
That's his statement. So he's very good. He's very clever. He's writing books and papers and giving conferences and convincing people. This is wonderfully clever, convincing people. That's the way it is, right? He works on the New York Times. I never did. What can I do? So, a logic is. I don't have to remind you about that. Logic is a consequence relation. Blah, 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 set of formulas and a consequential relation. It has reflexivity, monotonicity, transitivity in our way, not necessarily monotonic, but we accept that it's monotonic. Okay, we are working on this scenario that logic is like a Tarskian consequence relation.
But it follows from the other two.
Which one?
Monotonicity follows from.
Yeah, the monotonicity.
Monotonicity follows
yeah.
from
Well,
transitivity or?
It depends.
Transitivity and reflexivity.
Yeah, this way it does.
Okay.
But do you also assume like structurality, like closure under substitutions?
Yes.
Yes.
Yeah. Closure and substitution, etc. Only there's one point that's not going to happen. Is build to build like the algebras in a.
Yeah, I'm asking because then, like in this kind of framework, are all the contradictions sort of interderivable? Or I mean, are they like, they shouldn't be, right?
Yeah.
They are not derivable. Okay,
it's as close as classical logic. It's much, just with a small difference.
So your paraconsistent logic is monotonic. You have non-monotonic.
Yeah, we can think about non-monotonic, but not necessarily. Okay. So I like this. Eliminate all other factors, and the one that remains must be the truth.
Yeah.
I mean, that's the way of Sherlock Holmes working with a contradictory story, right? Very nice way. And we enjoy it very much because it seems to be crazy, like many movies are like that, seem to be completely crazy, and then you're separating it. At the end of the story, what you get must be the truth. So don't be afraid of contradictions. Eliminate them bendly. I mean, gently. Okay. But anyway, this is just something I like. Now, the systems. The systems are this generalization of Da Costa systems. Okay. Given a logic L, we started with a positive part of logic, the negationless fragment, and then the systems are particular LFI. So the LFIs are such a wide family that all Da Costa logics come inside it. Many logic is constructed by the Belgian people, like what's his name? Diederik Battens.
Oh, yeah.
Diederik Battens.
Yeah.
Go inside it. The logic that people work in Israel, like Arno Avron, Anna Zemansky, many other people, go inside it. Lukashevich, Yaskovsky logic, not Lukashevich. Lukashevich is different. Yaskovsky logic, D2, discussive logic, it falls within LFI. So LFI was this little idea of dividing the word into consistent and inconsistent statements. It makes such a big family that most of, or many logic is, consistent logic is, order logic go inside it, like, fall within it, okay? Like for instance, a theory can be partly explosive if contradiction entails just a subset of a formula, like this minimal intuitionistic logic by Komogorov and Johansson.
Yeah.
Right? When you have that by means of contradiction, you derive not everything, but only negated. So a logic can be partially explosive or completely explosive. Just an example. I'm not talking about this because this minimal intuitionistic logic is at the same time intuitionistic and paraconsistent.
Is T is
A theory. Given a theory, if you adjoin T, a theory T, if you adjoin T and not E, you don't derive everything, but just negative statements. All negative statements. Okay. Let's start with a starting point. The logical name is semin. Semin is nothing else than classical logic, including tertio non datur, with not the A implies A. You can put the other way around or not. You decide what you do. I mean, if you want to be more closer to intuitionistic reasoning, you don't add this principle. If you want to make it closer to classical logic, you add this principle. It makes no difference. Makes no problem.
how is it different from classical logic if I add the last one?
You don't have the law of explosion, like A implies not A implies B for every B. You know,
But these are the quality.
the only negated formulas are those here, these
Those
here.
last two.
They are not sufficient to derive this.
But these are independent one to the other. These actually.
Yeah, independent. You can prove it.
Need all that.
Is there,
Well, you maybe not. Sometimes you can make it. You can make a tableau system or a sequence system or a natural deduction system. But if I start with that one here makes derivations easy. I could make it simpler. Now, the point is that just by having this principle and this principle here,
And you are
algebra?
maybe.
you don't get or something like A implies not A implies B. So they are not sufficient to entail the law of explosion.
You're thinking of this as a Hilbert system.
Yeah, that's Hilbert. Yeah.
You have modus ponens?
Modus ponens, yes. Yes. Only modus ponens, that's all. I didn't write it here for some reason, but modus ponens.
There is something missing about the negation.
Yeah, you miss him.
It's not classical logic. There's things missing about the negation.
Yeah.
Okay, but
There would be one more axiom about the negation we would need
Yeah.
for that one,
Yeah.
which normally is there,
So there's no way to
but it's,
to understand
To derive it, no.
Yeah.
the algebraic
Yeah,
semantics
yeah,
of
sure.
this
No way.
thing
Yeah.
exists, otherwise I don't.
yeah.
there's no interaction between conjunction and disjunction and negation, right?
Some interaction, not as many as all possible.
You have some kind of distributivity.
It is distributive, no?
Yeah.
Conjunction, disjunction distribute,
Yeah.
like with the Morgan thing.
Positively to each other.
Right.
You don't have all of this.
Yeah, you wouldn't have the De Morgan, like all,
Some of them are a lot, not all of them.
just some.
I mean, you can't have all of them, right?
No, you
Then
can't have all,
that's-
Yes.
because that would be classical.
So what can we say?
It's
what
not
is
De
it missing?
Morgan.
There is no De Morgan.
This
Yeah.
is not De Morgan.
No, it's not a mark.
Even with the last one.
If-
Yeah, because
Yeah.
there's no
No,
interaction between say and and negation.
Yeah, there's no interaction between.
The action of negation are too weak.
Yeah.
The thing-
Complete negation.
Yeah.
Okay, there is an interaction between disjunction and implication. If there was some interaction between implication and conjunction other than in three,
Well, there is like, but it's
If the
not.
connector are not independent, that of course is.
But
quite
like you
different.
have,
They are primitive, they are primitive.
you have no interaction like of negation with implication really there, like much. So I mean, I mean, you don't have,
it's true, but
well, somewhat, but
it's somewhat right. because
Like
you
there's
have-
like-
you have nine. And
Yeah,
nine
yeah,
could
yeah.
be understood something like.
yeah, uh-huh.
Right,
Oh, yeah, like, but you don't,
but it's still there, but you
No.
cannot claim that the conjunction is the.
yeah,
Is
Yeah.
Yeah.
the reticulated, right?
Yes, yes. Actually, it's very hard to find an algebraic interpretation of this.
This I was
See?
wondering.
Yeah.
we wanted to
It's
see
very
one.
hard. For the following reason,
It's a bit.
because
There's
that's
a lattice
because
somewhere, right?
because you have a
A distributed one.
if you have A equivalent to B, you don't have not A necessarily equivalent.
Ah,
to
so
not
it's
B. And you have consistent A, not necessarily
What is
equivalent to
consistent
B.
A?
So you
Yeah,
cannot do
consistent A
a
is not
very
strict, though.
easy.
You have,
What is
what you
the
are saying, you have a very weak implication. So you are
Yeah.
this kind of like Nelsonian thing there that you need to. Or I mean, it also happens with like
Yeah.
clean logics,
Yeah,
right?
I mean,
Like this
The obvious
thing.
idea would be to construct a Lindenbaum-Tarski algebra.
No, but then you
You
need,
cannot do.
no, well, yeah, I mean, you would be using the wrong equivalence. You just need to strengthen your equivalence and then you should be able to do it, no? Like you say, okay, like my congruence is gonna be that A and B are equivalent and their negations are equivalent and their circles are equivalent.
Yeah.
There's
Or
no
I mean, but I
circle.
think the circle is actually like modality, so yes,
Yes, at the moment we're
So it
talking
should
about
be-
this slide,
It's like,
yeah.
and
There's
you're
no
saying it's
circle.
not algebrizable
Yeah.
in the standard.
But
no.
way.
It can be algebrizable. It can be algebrizable.
I know.
We have a very, I will tell you a story. Very recently, we discovered that if you add some actions to it, to some of these logics, you can be algebraized by means of a Boolean algebra with operators. This BAO.
Yeah.
I mean, kind of BAOs, and you can make a sort of you can have some, what do you call them? Is neighborhood semantics.
Oh, yeah,
Neighborhood.
that I would expect,
Yeah. But you have to add some action. You have to add some action.
but like we should.
And the funny story, as I was telling Mattia yesterday, that we discovered that by using Isabel.
Good.
And making all possible combinations, not working. Finally, Isabel said we cannot find any counterexample. Okay, so this must be a nice action. Let's put it there, blah, blah, blah. Then you work on it, it worked. So really, my first time in my life, I really used some proof assistant to help me to discover something.
But still, I would say we should,
Very
can
interesting.
try.
Just to tell you that. So I tell Mattia.
With this, we should like try.
Okay, so basic logic of inconsistent is named BC. You add to this simin, to this bunch of axioms here, you just add this principle, the principle of gentle explosion, right? So it explodes gently. A and not A plus A coherent or consistent implant. So if A is consistent and contradictory, then it explodes. So contradiction is not the same as inconsistent, right? Because you can separate the concept as we were talking in the beginning. So the following reduction rho, for instance, I can have gamma B, if gamma B entails A consistent and A and not A, then I get everything, got not B. Or BC relates contradiction and consistent in the following sense, as we're starting first, my first slides here. A and not A derives not to be consistent. I mean, if I have a contradiction, it's certainly not consistent. But if I have again, A and not A together or separately entail not to be consistent. But to be consistent entails not the case of be contradictory. Or again, Just vice versa here. The converse of these rules do not hold in the C. So they are separating. They are very much separating then inconsistent or not consistent from contradictions. Okay. Okay. What not provable? Some restricted forms of contraposition. If I have A and B, I want to derive not B implies not A, I need to have an extra hypothesis here, an extra assumption. Again, with this guy here, blah, blah, blah. Indefinability of connectives, A or B entails, it's not a case of A implies B, but not vice versa, blah, blah, blah. Intersubstitutivity of provable equivalence does not hold. All the provable equivalent, as I said, sometimes two guys are equivalent, the negation are not, blah, blah, blah. Okay, so there's some, I have to get rid of some laws of classical logic, right? Now, CI is another extension of this logic where I add this principle. Inconsistency of A implies A and not A. So inconsistent, by defining inconsistent to be negation of consistent. Now, in CI, inconsistent and contradiction are equivalent. As I said at the beginning, we can make them to be equivalent by paying the price of adding extra actions. Hey, if I pay the price of adding extra actions, I can do it.
So do we get now classical?
So this is not classical.
No, not yet. Not yet. Not yet.
So what's, okay, that's interesting.
Why not?
Because it's still, you'll be, this law of explosion will be missing.
Ah, okay.
Oh, it's
Still be missing.
Yeah.
So that you can get very, very close to classical logic. Important property of CI, for instance, well, this one I think is very nice. You can prove that consistent is self-consistent. So my sense of consistent given by these little actions are themselves proven to be consistent. And I'm going to use this in my project, Marco. You are my supervisor here to write my statements on Gödel's theorem.
So I disagree to be your supervisor.
Okay. It's too late. Your name is there already. So Mark agreed to me.
It's nice.
Mark agreed to me that we can use. No, let me tell you the idea. My idea was to make a reformation or to reform Gödel's theorem, changing the logic behind it, taking a weaker logic, and adding this sense of consistency. And I think I can prove again the Gödel's theorem. So Gödel's theorem is very resistant, very resilient. You can change the logic, you can change the notion of consistency. If you do it carefully, recover it again. It's a very formidable barrier of.
This is exactly what Gödel wanted, to have a proof that was as resistant as possible to any.
Maybe not. Maybe he was really would like his.
Of course, I don't think that Gödel had this in mind. No, certainly what he had in mind it was a proof that is as strong, as resistant as possible. That is in other sense, that use as less logic as possible.
Yeah. Okay, but I think Gödel will be very happy to see that you need less logic.
Yeah.
And another sense of consistency, you derive it again.
Of course.
So it'd be another Coop and Hilbert. Huh? Or a bunch on Hilbert. Okay, so I really like it. So consistency,
so why does everybody wants to punch Hilbert? I never understood
Hilbert,
it.
because he is German. Because of the,
Yeah, maybe that's the explanation, and that's why I didn't understand.
you know
it.
what Einstein said? You know, Einstein said, when they do something right, they call me German. And they come something wrong, they call me Jew.
But that's not an answer to my question. Right?
No, I know. I know. It's not like that's Hilbert. He was sort of, you know, if you read
I mean,
his
he found
biography.
proof theory, right? And now he's the all the proof theorists kind of say bad things about him, but I just don't get it.
No, Hilbert was a genius. But
Not all.
if you read his,
I'm just talking about what I'm
Statement.
hearing, right? I,
Yeah.
I didn't do any data analysis.
if you read his statement, he said once, okay, in a conference in Münster, I think it was in Münster, he said, the consistency of mathematics is done. It's already done. My assistant, Paul Bernays, will explain to you in the next days. Paul Bernays. Paul Bernays was there. I have to do that. Do I have to? Prove it.
Yeah, but this is also not, I mean, I don't get it. So people talk bad about Hilbert because they don't like him as a person, but it's
No.
not a statement about his kind of mathematics. Or,
No, people
but
don't-
we're talking about mathematics here. So
No, people don't talk bad about Frege, for instance. They love Frege.
I don't know. I mean, I just.
No, I don't know that, like, but it's not like,
I hear all the time, oh, Hilbert's program failed. To me, this is obvious nonsense to say that, right? So Hilbert's program was one of the most successful programs in all of mathematics ever. So like, why do people say these kind of stuff?
It's ask Gödel.
I mean, Gödel's theorem wouldn't exist without Hilbert's program. Gödel's theorem is proof of the success of Hilbert's program.
That's true.
So like,
That's very true.
I don't
In my
understand why
position as
you always
supervisor,
repeat these stereotypes.
in my position as supervisor, I suggest that this discussion take place in another conference talk.
Yeah.
Because this is a completely different.
Yes, yes.
Okay.
Anyway,
But I think that it would,
this discussion.
in my
to
position as
provisions.
supervisor, I suggest to have this discussion in some.
Over a beer. Okay, Alex.
No, not over a beer.
Over a beer, why not?
yeah, over a beer.
So but anyway, I like it. I like those properties. So consistent is consistent in this sense, in its own sense, right? Inconsistent is also consistent. What does it mean? Does it mean that I cannot have something like ball A and not ball A? This leads to an explosion. Because I already have consistent as a theorem, right? So consistent itself cannot be considered like a vague or soft notion. Consistent is a hard question.
Is it like once I put any of the circles there, I'm becoming kind of like classical?
Yeah, if I
Not
put
really
if I put
like-
around, if you put a white ball everywhere. it
Well, I mean,
becomes
yeah,
classical.
I mean, if I put the white,
Yeah,
so,
it becomes classical.
but also like if I put like black things there, then since it's a negation of white, like, I mean, I'm sort of like big negation of white, but I'm sort of also, like, I'm talking about it, it's consistent to be, like, inconsistency is also like safe to, because like,
Yeah.
safe to reason with, because
Yeah,
like,
exactly.
you,
Just
Yeah.
upside down.
Walter, a stupid question.
Yeah.
well, it's,
Is this the same as this? So when I have A, then I means that this is, all these are two different.
No, this is one of them implies
They are equivalent.
No, in this logic they will be. In this CI logic they will be equivalent. Yeah, but not necessarily.
general.
Not necessarily. Yeah. Let me go to the semantics. Okay, now, oh, sorry. Any classical reasoning can be simulated into the logic CI and in BC as well. Why is that so? Because in CI you can recover classical negation when coming back to our first question. If you define like a strong negation of A,
No.
it's not soft A and A is consistent. Then I get one possible definition of strong negation, or A implies A and not A, this guy here, this definition here. Then I get another strong negation equivalent to one. So I can recover classical.
equivalent to it?
They are equivalent to negations.
Yeah, they are.
Okay, so it's like
On which
Yeah, on which-
framework?
In the CI logic.
in the CI, I need
Oh, CI is, no, that's something very interesting. So CI is a subclassical logic, but classical logic can be translated inside CI
yeah, good,
and in a weaker BC.
yeah.
So sorry, I still don't understand why you read circle A as A is consistent. Right, circle is a modal operator which takes A and produces a new formula.
Yes.
Circle A. So it's not the case that the A becomes consistent because I write a circle. When you say A is consistent, it suggests to me that suddenly A is consistent. But
No.
all that's going on here is that you take an A, consistent or not, and you write a circle in front of it.
It's like if
So
I write this.
I think I'm still kind of just at the, I'm still on slide 1, trying just to figure out like how to connect the mathematics, which you now presented to us and which I understand it to some extent, to the way you're talking about your mathematics. There seems to be this gap for some reason that I'm not able to bridge.
Let me see, where am I building a gap? So you are
You
telling
say
me
A
mind the
is
gap.
consistent. I don't see this in the formula. When I look at the formula, I don't see any A that is consistent. I see an A and I see a
But
circle
it's,
A.
yeah,
I don't.
but it's like, I mean, like A, I would read like A is the case, and circle A, I would
No, but
read like A is consistent is the case.
Advantage.
It's like if you put
But this
knowledge
is the
knowledge in
case,
front
it's
of
usually
formula.
outside of the formula. You take a whole formula and then you say
Yeah.
this form. But no, but here we're looking inside the circle
Yeah, yeah.
is in the formula.
But it's a
It does
modality.
not make
It's
sense
a
to say A
modality.
is the case.
It's a modality. It's like
Yeah.
knowledge. It's like knowing A is the case suddenly. So this is like A being consistent is the case.
What would happen if you replace if you do the same argument with
Negation.
Yeah.
When I write negation, is this true? I don't know. Negating the formula can be false.
Yeah, it's just a modality.
When I write a negation, I read the formula as not A.
Not A, then I would write
just a
consistent,
new formula.
consistent A.
yeah,
It's a formula.
but repeat the same argument. Well, what if he was using the same language with negation? Maybe this is going to clarify. He would be saying A is false.
No, but I mean, the not A here is part of a formula. The formula
Yes.
not A and circle A is not saying that A is false.
But he would
It's
be,
just making a statement. It's just
That
making.
A is consistent.
It's just
but he would be saying that,
he would be saying that.
right? He would
And
be
I
saying
would probably be also confused again.
exactly.
Because it's not, it's not what you should say if you read that formula.
Exactly. Yeah,
You agree with me?
Yes.
Okay, so, okay.
I'm just making your point stronger
So
by saying.
I'm not
Let me see,
alone. with
where's my gap?
with
Where's my gap? Where am I gapping? Where am I gapping? I mean, where do I make a difference between mathematics and my space making? For me, it's so clear. So this is like a sign of negations. It's a sin categorematic sign that you can put over, instead like it,
Yeah,
like
but
a
this
square.
sign doesn't change the A.
like a square.
It
doesn't.
takes an A
If
and
you
creates a new
put a
formula.
square.
Yes. Circle A is a new formula, which means
It's a
something
new
else than
formula,
A.
like, you can make it, you
Yeah,
can
and in
make
particular, it doesn't mean that A is consistent.
Well, I want it to mean that A is consistent. Like circle A, I want to mean, like, I mean, KA, I would want to mean that the agent knows A. So it's like a
Agent
modal
knows A,
formula.
okay.
It's a different formula with a different meaning than A.
maybe not no, maybe agent tells you about it. Perhaps, like in this.
Well, there's a bit
Belknap-
of like this
Belknap and done
cautious
logic.
reading here, if the reading here is a bit like hiddenly epistemic in some sense.
Yeah, it's epistemic and it's like a
Then-
reality, only I don't have it
It's-
possible words.
Then it's not clear, yeah, then.
I don't have possible words, I have impossible translations. I'm going to show you in a moment.
Yeah, that we need to see
Huh?
because
So I really, Alex, I don't know where I'm gapping, sorry.
Okay, so
I think
no, but yeah, no, I won't repeat myself. I think at least I can try to translate your way of talking about it into a way I can understand. I will not ask you to bridge the gap. I will try to do it myself, but
But you can discuss, of course, anytime. I'd be very happy.
What you said helped me a bit. Also, what you said.
My intention is really to discuss with you, to have your reaction, and that's very, very important for me. If your reaction is, there's a gap between what I say, when you are right, I'd like to know. Maybe I can bridge the gap
meaning
myself.
of compound formulas is not exactly clear, but because it comes from semantics. So
yeah, we don't,
you define the
we need
still the
semantics.
negation, and it seems to make some sense. But what if you say A and circle A? What is the meaning of A
And circle A mean A is true and consistent. It's really true. It's not this kind of half more or less true.
So usually when we say that something is consistent, how do we use this adjective? We say that a theory is consistent. we say that a formula is consistent if the theory that is generated is consistent,
Yes.
right? Consistent is something that we predicate about
Mm.
theory or a formula within a theory, within a logic, right?
Yeah.
So to say that a formula is consistent in itself without a reference to a logic doesn't mean anything.
But sorry, why?
Reference
we
to
do
this
not-
logic.
But why we do not think a consistent sense simply to say it supports explosion, not consistent. So what does it mean?
What?
Around E, that E
I see
and
now what
not
you, yeah, I
E
see what you're
give
saying.
explosion. So I think that is the only way, reasonable way. Other philosophical construction are quite arbitrary. It is what it means. There are some formulas that support explosion, others that do not support explosion. Point. Why we need to add something more?
Yeah, so it's like a negation. Do you agree with me if the negation has no meaning outside the logic?
So it depends. So,
Well, no, in traditionalistic negation is one thing.
but
No, it,
but
Other
yes.
classical negations are not.
But negation is something that you apply to
I
a
need
formula. You say,
yeah,
the formula, it is raining, apply the negation, it is not raining,
Mhm.
I
right?
need to go to
And
my
then-
car, otherwise.
But when you say something, the formula is consistent, this is not something absolute. The formula is consistent within this logic.
State, yes, of course.
I mean,
Like negation.
it refers to the consequence
It refers
of
to
the same, that I, like, I mean, if I just use negation, it doesn't say actually A is not provable.
Exactly.
And if I'm being
saying that-
intuitionist, I need to explain what I mean by negation if I start suddenly saying like A is not provable. Because then I say like where, how, and there's the
Yeah.
whole business. So I mean here, I mean, the confusion might be that it actually refers to the same consequence relation of which it is a part.
Yeah.
Is it like?
A little bit, yeah.
I mean, I don't know what was the problem, because I say, it's a statement, like I say, if I negate a statement, I say it's
Yeah,
not the case.
Yeah, but like we
If I
are,
say-
we are
if I
not
put the
saying it is
consistent
wrong.
order, it's
like now,
statement
I mean, we have just the syntax, so it makes perfect sense. We just like, we are just digging to the reading of formulas because it's not in, like, it's problematic, and the semantics should actually kind of explain what's going on. Or maybe the translations would,
That's why we wait
Yeah.
to get there. The-
and we keep stalling you with questions so that you
So
can't
use
show
other
us the
formulas
semantics.
that have this,
I see what you're
this
saying.
background, like for example, soft, hard, as you were using before, I wouldn't have any trouble. So you just say soft A, that's so meaning A is soft. Okay, negation of A is not A, the other one, okay. But when you say it is consistent, then I am thinking that there is a whole logic, a whole deductive system in which this is, if you add that to that logic, something, then this is something that's going to happen to that. But it is not that.
It's a local
It's just a
consistency.
formula.
It's a local concept, it's not a global.
One question might be, here, the circle is used as a unary function, so
Mhm.
at
Yeah.
the connected level.
Yes.
But a concept like consistency could be considered just a unary relation at the atomic level, because like you said, in your database, you have to decide which of the facts in the database are hard and which ones are soft. And after that, you build the logic.
Yes.
And you decided to build the logic with the unary functions.
Exactly. For example, what would happen if you write the circle X, where X is a variable?
It will,
What would be the meaning of circle X?
depends on what you plug into X.
Yeah.
We need to see the semantics.
Yeah, we
before
need
we
to
can
see
have it.
Okay, let's see it.
Yeah.
It's like, do you consider arithmetical statements consistent?
But would you say, for example, the variable X is consistent?
No.
Does this make sense?
Statements, variable X is not a statement.
But you can put the circle instead in front of a variable. A variable is a formula.
Proposition there.
No, but
Propositional
proposition,
variable.
proposition.
Proposition of verb is okay, it's a their statement, it's a kind of a meta
Oh, okay.
statement.
But it's like sort of always consistent, right? Or something, because, yeah, I see what,
This white circle is a marker so that the axioms can be written.
yes.
Is it a marker or is it a unary modality?
It's a unary
modality.
connective,
This is
unary
So
connective.
that you can write complicated
But
formulas,
it's-
but we're currently arguing about something that we can only decide whether it makes sense when we see.
Please show us the semantics. Yes,
Because the
any semantics or the
syntactics is
translation.
clear. And the Hilbert system is still a little mysterious. We've seen something,
Mhm.
so we could
Yeah.
think of what that Hilbert system allows us to say about simple unary modality, but the semantics is really what it's supposed to be saying.
Yeah.
And then we can argue about the language is reasonable.
Do you consider a negation modality?
Yeah,
Depends on the setup, yeah, can be.
Can be, they are the same, so the ball is a modality
any
as much as
unary
negation.
connection can be thought.
What is negation is? Okay, let me go to to the semantic, but I'd like to Marco to be here because
He'll be back.
okay, by appropriate defining proper thousands of laws can be defined. Then you can add the new other axioms. You can think about if consistent can be, for instance, governed by this axiom. If two guys are consistent, then their composition is consistent or not. You decide it. Okay, you decide if you add this axiom or not. You decide if one of them is consistent, then the composition or the complex formula built upon disjunction, blah, 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 is again consistent or not. I mean, you can think about consistency as a genetic trait, a genetic, what do you say, trait, or a genetic pointer or property, yeah, genetic property. Like if one of the fathers or mother has this property, is inherited by the sons, or you need both, they are recessive or not recessive or dominant. You can think about that. You can make many other choices like that, and then you are getting close, making these choices here. You are getting closer to this very much complicated Da Costa logic, where they are much complex because they have this propagation of consistency, blah blah blah, and then in the principle we don't need it. That's all the beauty of our approach. We started from very little logic. We did not start from Da Costa logic. We are approaching Da Costa if you need, or Buttons, or other people, or I don't know, trivalio the paraconsistent logic, your P1 or LFI1, blah blah blah, J3, or other logics. Okay, so anyway, many more choices you can have like a 2F13, like 8,000 different trivalued logics, for instance, just by plugging new properties. Okay, I mean, Marco, I was just saying that by plugging new axioms that talk about propagation of consistency, like if both of them are consistent, then the molecular formula is consistent, or one of them is consistent, molecular formula is consistent, blah, blah, blah. So by adding this kind of propagation, you get closer to the original Da Costa logics. So Da Costa logic is going to be a very particular cases of our logics. Now, let me try.
You mean that Da Costa logic is closer to classical logic than yours?
In a sense, yes. It's hard to say. It's hard to say what's to be closed or not to be closed. Even yeah, if you regard like a consistent to be a inherently classical property, it has more properties concerning propagation of consistency. So let's go to the semantic. Semantics is possible translations and this Rosetta Stone story. Yeah? That's more or less the scenario that I'm going to tell you. You know, the Rosetta Stone was discovered like people could not read the hieroglyphs, right? So what they did, there's Champollion. The French are always finding new things in the desert. They found that, and this stone, and they said, okay, the stone had three different writings on it, like a Greek, Demotic, and he said, what if the Greek and Demotic have the same meaning of as the hieroglyphs? He made a supposition. Suppose they do. If this is the case, then we could start deciphering the hieroglyphs, and they did well. And later on, they discovered more and more evidence that his supposition was right. So the real supposition is to try to think about something complicated as hieroglyphic translated it into things that I already know. Okay, that's the idea. And then the translations given a logic and another logic. A translation from L into L prime is a mapping between formulas that preserve the consequence relation. I mean, if gamma entails A, then gamma star entails A star in another logic. And the translation is said to be conservative. It goes all the way around. Okay, that's well known. Now, what I call soft hermeneutics, the possible translation semantic is like you take a bunch of easy logics like that. I mean, I make a kind of a drawing here. You have a complicated logic that you don't know which semantic is it you would have. And one important point is, let's take the logic CI. CI. That's one I just showed you. You don't know what the kind of semantics you would have. It's complicated. There's no algebra inherent to it. So it's not, not important point. It's not many valued logic. You can prove that like in modal logic, it has no possible many valued semantics. So the idea would be the following. Perhaps if you translate all the formulas into three valued logics by means of translation, I mean, this would be simpler but a consistent three valued logics, but they already existed.
Yeah.
Okay. So if you translate them into by a certain meaning of certain very specific meaning of translation into bunch of three valued logics, and then I ask you for the meaning of a sentence here. If all the translations agree that it's a tautology, then it is tautology there. Okay, like in a committee, if I have a complicated question, if I ask the opinion of everyone, if you everyone vote positively, then the story is going to be voted positively.
But isn't it there that I can, in principle, use these like, I don't know, 3 or how many simpler thingies and sort of like figure out what construction abstractive would give me a semantics for CI?
Yeah.
Like if they have algebraic semantics, then I can hook up some kind of sum.
Exactly. Yes.
So yeah, but like I mean, if I manage to do this, then I mean I can hope to sort of see what I should do with these algebras for the simple things to get.
That was exactly.
There must be some abstract construction.
That was exactly the masterpiece of Juliana.
Okay.
Exactly. I show you. Yeah, she did that exactly. So I mean, come back to going back to this semantic. So the idea is that this is complicated. It does not have any clear semantics, not many valued, not possible worlds, or anything that I know. But if I can divide it or sort of by using translation, like in a committee, that's a very nice example. Now, a committee of people that are judging a profession, hiring a person, and okay, what do you think about him or her? What do you think? What do you think? Okay, if all of us vote positively, and that's one possible scenario, right? If you need unanimity, or you may say, no, we just need majority voting. But for logic, we need unanimity. So if the unanimity of translations say that the translated formulas are to be regarded as tautology, then the biggest complicated thing is a tautology as well. Now, my only problem is to prove that this is true, to prove that this gives a real completeness proof. Right? Otherwise, it's just an idea. Anyway, that's what I did. Okay, the idea of possible translation semantics is like that. For instance, the formula, it's not a case that is consistent, not A. We will have in principle 8 possible distinct translations. So because why? Because I'm using these specific translations. I'm using this specific translation here. So conjunction will be regarded as a 3-valued conjunction. Disjunction has three values disjunction. Implication is a three-value implication, but negation and inconsistent will have two separate meanings. Sometimes, T, small t, and F. I'm using these three-value scenarios of two distinguished truth values. So
Okay.
one is not good. It's not badly written here. The weak,
Oh, I see
the weak
what you're-
meaning,
okay,
the
I
weak
see what you're
meaning is like translation of true is F is true, and I mean,
Yeah.
more or less true or intermediate true is becoming intermediate. So the weak sense. The strong sense is that
It's becoming.
I regard true as really true, so the negation is false. False as really false, the negation is true, and intermediate true as real truths, and this negation is false.
Right, I just,
That's
sorry
what-
for interrupting, but I have to go,
Okay,
right, so, yeah. So-
you're going to miss
Well,
the
we can-
most
we
important
can
part.
talk- Yeah,
I
sorry
can
for
repeat,
that.
I can repeat for you.
Yeah,
I'll be
okay,
very glad,
yeah, okay, thanks.
because I needed people,
It's very thought provoking. I want to understand it better, but I have another meeting now.
no, but okay, any other time
Yeah.
I can speak again,
Yeah.
no problem. Okay, thank you for coming. So, so I have two distinct meanings for negation and two distinct meanings for consistent. Again, consistent is regarded as true, intermediate, or false. The weak meaning is if something is true, consistent is true. If it's false, if it's real false, it's real consistent. So it's true.
Because it
It's
makes-
consistent is true. I mean, the consistent about something false is real true. And the consistent about an intermediate is true again. Or other way around, the consistent about something intermediate is false. So I'm varying the meaning of consistent and I'm varying the meaning of negation. Just in a very simple way. That's enough. You could say, why you don't use more values? Because I don't need them. It's enough to use them.
Can you go to the previous slide?
Yes, please. Have a local force relation.
No, the previous.
Okay. Now, okay, so because I had these two meanings, right? Only two meanings for negation and for consistency. If I have this formula here, I will have, it will be translated as weak negation applied to this guy is going to give me, okay, I will give me weak, strong, weak, strong, strong. Okay?
Those are going to be different translations.
Yeah.
One of those is going to be different translations.
Yes. There are a finite number of possibilities of translating it. Because I only had this. Because I have this. I only have two ways of translating here. And the other guys have been translated in trivial logic as.
Can you, I like your tables, but I don't quite understand how it works. You go to the tables, the
Yes.
small tables.
You hear?
Yeah, the conjunction.
Yeah.
Definitely true and definitely true. It's
True?
only provisionally true.
Two gives me back two. I interpret both truths as intermediate truths.
The result is just intermediate, but I don't understand why.
Why is intermediate? Because then I have a room to use this T or either for F or for, if I had big true and big F, the translations will be fixed. It's not flexible enough.
So you need that flexibility with conjunction of two absolutely true.
Yes.
Okay,
Alright,
that's
the
interesting, because that's what
the
I-
logical stuff gives you this.
Yeah.
Okay.
Because you need something like A and not A, not to be.
Exactly,
Yes,
Have this
yes,
conjunction
yes.
there.
exactly.
Yes, I got it.
Yeah, I see.
Yes.
Same.
So, and then I use this possible translation. What are the possible translations? All possibilities of translating it. And I translated these things it's not deterministically, right? So either using a strong or weak negation to translate, strong or weak consistency to translate. And then for each formula, I build a finite number
Yeah.
of translations. And then I can decide it very easily. I go to trivial logic, I decide it, and I decide my logic back.
So now something that what you just said then makes me think that paraconsistency is not only a matter of negation, but also a matter of conjunction.
Uh-huh.
Yeah.
It's as much as
Uh-huh.
conjunction as
That's
negation.
a very
Maybe
good
it's
point.
both
That's a
technical,
very
but-
good point. Yeah, that's a very good point. Yes.
It's actually,
Or
Uh-huh.
implication as well.
Yeah.
yeah, it's
Uh-huh.
it's a matter of conjunction, disjunction, and implication, and it's not a matter of.
Negation.
Yes, that's not a
Negation
matter of
is
negation. Yeah.
In the tables, maybe the weak negation is a little bit permissive, but the
Yeah,
other
but the
one
other
is,
one.
is like, yeah, so
Oh.
I'm surprised because I would have thought that my weak negation is the one that introduces the variability, but not according to this thing.
Yeah,
This
according
is
to
a
this
specific
interpretation.
choice of semantics, and
That's
it's interesting.
And then I can prove it. I can find so the possible translation semantics would be like that. So I take, for instance, Da Costa's logic, CN, which had, as I told at the beginning, this very weird semantic, 0-1 semantics that did not explain anything.
Mm.
Now I think I can explain because I can translate either any computer will be able to understand my translations and to decide them. And I can explain to an alien, extraterrestrial, what I mean by paraconsistent. Even an extraterrestrial understand.
So, do you have a completeness, full completeness, meaning that if a set of formulas,
Thank you for coming.
a set of formulas implies a formula and Da Costa, if and only if all the translations satisfy this?
Yes.
Depends on your translation.
Yes,
Yeah,
yes.
yeah, but all
You
these
have lots
Yes,
of
I have.
different ways of
Yeah,
Yeah, I can say, I'll be very glad to
Yeah.
send you the papers or to put them in a repository here if you have, because here we have,
You
everything.
Add it to your, yeah, please send me.
Yeah, I
Put
will.
this on the GALAI page.
Is there a GALAI page? I can put everything there.
Yeah.
Okay, I don't know how to, I send to you,
Yeah.
you put that,
So-
okay.
The way that I understand this is that those translations are transformers. And given a transformer in a logic here, you can generate this logic here using the transformer, right? You translate the formula, you calculate there in this logic, and then you go back. Right?
Yeah.
So every closure operator here is going to generate a closure operator here. And what he's doing is taking the intersection of all the logics that
That you
are
need to
produced here
agree.
by translations
Yes.
into all the logics.
Yes, yes, yes.
Designing the semantics of CN
Yeah.
by combining the existing semantics.
Yeah,
But finitely many.
yes, true, exactly. So here I use as a target, I use this LFI1 logic, it's a J3 or three-value logic. Was studied by Da Costa and Italo Dottaviano and by my students and their other names. I mean, yeah, this is a very simple three-value logic in which it has semantics, it's decidable, it is algebraizable. Okay, so then I can think about your question.
Yeah, I think.
Okay, but that is examples. Okay, well,
Then you should be able to do something about.
Yeah,
Because like,
you can translate the formulas, and then of course, you are going to have a finite number of translations. You,
so, I mean, if I can translate to finitely many algebraizable
yeah,
logics, then
yes,
I don't know that. Is the intersection of those things going to be algebraic?
no, like, I mean, but like
That's it.
that is there is that I have like different translations. Like, so I mean, I'm looking at a single thing here,
Yeah.
but then I produce like finitely many like versions of the formula, and I'm looking like at different places. But it sort of means that maybe I can cook up like some algebraic semantic for the whole thing.
okay, that's what I mean. Algebraizing field translation, right?
Uh-huh.
That's what
Yeah.
master
Yeah.
thesis was exactly was under Marcelo Cornelio, was this kind of thing. So she put the
Okay.
translation here.
You should
and work
talk to
on the
her.
on the algebraic here.
Uh-huh.
And show that the bunch of algebras can be regarded as a kind of
No, then
algebraizing via translation. It's a very nice idea.
we need to let
Yeah.
her tell us,
Yeah,
because we are interested,
Yeah,
I
yeah.
think, in this point,
yes,
and see what's what there. Yeah,
yeah.
no, nice.
There are block Pego's algebraizing, for instance.
Uh-huh.
Okay, then,
Yeah.
But are you saying that your logic is compatible with different semantics? And so any translation correspond to a different semantics, and under any of them it is complete.
No,
No,
no.
it is that
Just a bunch of semantics together made a completeness.
Yes, exactly.
Close together.
to be correct in C1, for example, to be correct in C1 means that it has to be correct in all.
Yes, yes.
You just
Has to be
know-
unanimous. There has to be unanimous in all of them. Yes. Okay, let me give an example if you have time.
Yes, I understand. Yes.
Yeah. I don't know if you like this Clyde, a lot of toy examples. Let me try to give you a toy example of a belief revision, the story of the stolen diamonds. Yeah. So a diamond was stolen, and only Adam and Bobby were present. Since there are no proofs, but the only evidence against them, the jury cannot consider them guilty. So his belief basis is Adams is not guilty and Bob is not guilty, but it was a crime. So the belief basis we started is not A and not B. The guilty, right?
Yeah.
A and B. A means statement means A is guilty. B means B is guilty. Not A is not guilty, not guilty, etc. Okay, but any judge works under a soft negation, is that? No people in this world uses classical logic. Not even crazy people use classical logic because they derive crazy things about any contradiction. Like if I ask if there are baker around and people say yes, or people say no, and I derive that Mark is going to be the Pope and not to be the next Pope simultaneously, right? So, okay. So the judge puts some kind of a soft negation. Okay, for the moment, for a while, they're not guilty. Let's see what happens. So if you take classical logic seriously, you would explode the thing because you have not A, not B, but A or B. Huh? Later on, if the Jews use the classical logic, you derive everything because this knowledge base is contradictory, but he does not. Okay, the Jews' attitude, he's sort of, running a tableau, etc. It's not important if you're running a tableau or not. But a new investigation discovered that only Adam used the car since the diamond was stolen. So he's sort of remaking or rebuilding his belief basis, and now he has, okay, it's not A, not B, one of them, and it's consistent that B was not there. B is not. Now it's consistent that B is not guilty because only Adam used the car. So now B's supposition about Bob's innocence is indeed consistent. So he started supposing that, now because of the world, it's not a logical matter here. The states of these things in the world told him that B must be guilty because only B was present in this crime scene or scene. Right? So this is a way of making. So now using CI, he decides that A is not guilty, and this innocence or this culpability of A is indeed bad behavior or incoherent, inconsistent. Now the judge concluded that A is guilty, and the initial assumption about his non-culpability was inconsistent. Finally, logic close to common sense. My goodness. I'm very happy with this example. That shows how we can use real logic, a formal logic, to model reasoning of real people. Like Marco, this is very important for the philosophy of science, because that's what the philosophers of science do all the time, make mistakes.
Yes, but this example, at least, you introduce a sort of temporal dimension.
Yeah.
And the logic in general, this classical logic, is supposed to be atemporal. And so, if I were a defensor of classical logic, I would then know against your logic, I would say your example is not very good. because in fact you change the data in a certain moment. So I
course,
can still
I-
the modeling it with the classical logic, but if I introduce the temporal.
that's what the people do is belief revision, right? How do people make belief revisions? Traveling on time, I mean, on moments of time or different stages.
I'm not arguing that traveling time is not a good thing. I'm arguing that if you introduce time, you can formalize the case that you described in classical logic. You don't need paraconsistent logic. Because then you have a certain theorem, a certain
Don't
theorem,
believe
and a
it.
theorem.
How can you survive
Because
this?
you have A.
How can
or-
you survive this?
Because you have A or B, and you have that B is not, so you have not B, so you can.
How can you survive this?
Because I have A and non-A.
An A or B? You cannot survive it. You need some logic. It does not lead to explosion from that.
I would say that non-A in T, non-B in T, and A or B in T minus one.
Okay, but then you solve any problem.
Solution you showed us is not that.
Yeah.
Yeah.
No, because here I can say, okay, someone has been guilty. Now I do not know. Now I cannot say whether this is guilty or this is guilty. So now both of them are not guilty, but before someone has been guilty. So I think that I can work with it. I do not want to say your example is not. I want to say that you use your example by comparing two different things. So you.
But like even people working in belief revision, they have the same. So they would say, okay, I don't need any belief revision because
I
I'm.
tell it another way. I think that your logic formalizes very well belief revision. Okay.
Yeah.
But this does not mean
You don't believe in belief revision.
No, but this I do not deny. I'm not denying that your logic formalizes well belief revision. I claim your logic formalizes well belief revision. My claim is this does not entice the classical logic that cannot formalize well belief revision.
Yeah.
Can be. Actually, if you use my discussion discussed this many times. If you use a paraconsistent logic, you don't even need belief revision. You can survive with contradictory beliefs. I mean, that's a philosophical attitude that you have to buy or to stand for, right? Yes. Philosophy has points of view. Anyway, this is an example that you can, without using time, your very simple model, you can put everything together in a databases, right? Nixon's diamond, for instance, this example here, very famous example. Nixon is a Quaker, Quaker pacifists, and Nixon is not a pacifist. That's a very famous example of artificial intelligence. So how can you solve that automatically? If you run a tableau for the, you can use this tableau for this kind of logic is very easily, and they have more or less same property. If you run a tableau automatically, you put this question for a artificial intelligence agent, equip it with this logic, you can say the following. So it's true that Quaker is Nixon is a Quaker. It's true that any Quaker is pacifist. It's true that it's not pacifist. Okay. Then you obtain blah blah blah. You close the tableau, and you get an open tableau. An open branch here. You close all the branches with this kind of tableau, and you obtain an open branch that explains to you what's happening. So the concept of being a pacifist is falsely consistent, is not consistent. So the only possible explanation is that because Nixon exists. Nixon is a Quaker. Quaker are pacifists. So the idea of who is pacifist principle, right?
Yeah, I would say
Anyway,
that
I would say
Quakers
I
are
would say
That's one explanation.
it's not always like
Because 1 and 3 entitled to a false.
Well, yeah, I would expect that there would also be a possibility that like something gets wrong with two, but like you assumed it like with a T in front of it. So
yeah.
I would say that it also can be, okay, then maybe this implication is
Yeah.
just softly true or
Now,
something.
what's the meaning of the kind of
Or
little,
like it's not like,
what is the meaning of this kind of little examples? That you can use it to make abductions,
yeah,
you know?
that,
That opens the door to abductive logic.
yes.
And we have a paper on this kind of thing explaining how
Yeah.
paraconsistent logic can help you to make abductions. Well, that's the only possible explanation. No, that's one explanation. But it's quite good. If you have a formal system, a simple formal system, that it helps you to build abductive reasoning, it's good enough. Right? Other concepts of possible translation, society semantics. I worked with Victor Fernandez, Mamed Lima Marques, Marcelo Cornelio, and providing algebraic semantics, as you said, for consistent logic in the possible translation of algebraic semantics by Juliana. Then what are these systems? So the logical form inconsistent are, I think I consider an important subclass, the system that are able to express the notion of consistent and inconsistent as pure logic notions. The aims and techniques that LFIs produce a remarkable unification of the paraconsistent terrain, except the one little logic by Graham Priest, it does not fall into this thing here
I mean,
because it's very weak.
parallel?
LP logic. It does not fall because it's too weak, super weak.
Okay, yeah.
You can extend it a little bit. You can extend it with
course, like
this
you can-
ball, yeah. But the way it defines is offer a new view of the Brazilian approach to paraconsistent logic, and also suggest the idea of LFAU. I mean the opposites, logic of formal undecidability, which is logic is of incomplete information yet to be done. But now they are done. This paracomplete logic. Okay, so the big references are those papers here. I'll send to the GALAI page.
Yes.
And this book by Marcelo Cornelli and myself, which sort of encompasses like 30 years of studies in this logic and lots of material here. Lots of material. I'll send to you, Peter. And so I have only advice I have to give to you by St. Francis de Sales. When you encounter difficulties and contradictions, do not try to break them, but bend them with gentleness, like in jiu-jitsu. Try to overcome with gentleness. Don't not break things. That's what I like to tell you.
So you finish with a slide to say that you are a very gentle guy.
Am I?
You finish the slide that say that you are a very gentle guy, not only a good logician, but also a gentle guy.
Suppose.
Belgium.
Thank you.
Okay.
Thank you. Welcome. I'm open to more if you like the idea.
I think
There are
that,
many more to say.
this is very nice. I think that perhaps after Christmas, because we stay here more months, we could have another about your global project, because this is very
Yes. Sure. I can explain to you. And I'll be giving a lecture on, I don't know when. I have a next lecture scheduled really.
Your lecture for MPP?
Yeah.
Only 3 weeks, no?
I don't remember. It's there. I don't know.
You should stick in 3 weeks.
Yeah, 2 weeks, I guess. Okay, good.
I would also be interested in your project you mentioned at the beginning, Isabel. You could show us ways in which you did this.
Yeah.
Thank you
Excellent.
very much for this.
Actually,
You can do it in GALAI
I
sometime,
think
because
we
it's
did,
nice.
we put this in this. Thank you very much. Thank you. I think we put this in the archive of a formal
Mhm. Okay, I can look there.
something.
I can look there.
Yeah.
Yes.
Perfect.
Thank you very much. Thank you for. Jose, this is your computer, right?
Yes.
You can